Okay, so welcome to one of the most important, if not the most important lessons in geometry. All right, so we are going to be dealing with unknown angle proofs. Okay, we're going to be writing proofs. Now, what is a proof? Well, remember something. One of the main goals in geometry is to develop your ability to reason critically. Okay, if you can do that, then you can pass any test, and this transcends to English, social studies, global. Okay, critical thinking, okay, critical analysis. So you need to be able to draw valid conclusions based upon observation and proven facts, the facts that we have been going over and over and over throughout this past couple of months. All right then. So for example, let's look at this diagram right here. Okay, there is something called deductive reasoning. Now, deductive reasoning is based on, you are supposed to prove something based on facts, based on theorems. Okay, that's how you do it. So for example, let's revisit an old friend. So solving for unknown angles. So this is the diagram, right? So you need to figure out the measure of A, and you use the fact that this angle, the exterior angle of a triangle, is equal to the sum of the two non-adjacent or two remote angles or two opposite angles. So 78 was the same thing as 42 plus A. Okay, so then making A 36 degrees, because 42 plus 36 is 78, and that's how you found the value of A. Okay, now the measure of A must therefore be 36. Now suppose we rearrange the diagram just a little bit. Okay, so now let's say this is your diagram right here. Okay, and let's say that we want to prove that x plus y equals z. Okay, in other words, that the exterior angle, okay, of a triangle equals the sum of the two opposite interior angles. Okay, so how am I gonna conduct this proof? Easy. There are two ways of conducting a proof. One is what I call the essay method, and the other one is a two-column proof, which is a formal proof. Either or, as long as you write a series of statements and reasons. In other words, claim and evidence. Okay, your statement, the facts. All right, so for example, I hope you can look at this. I hope it's clear enough and you're watching on the computer. All right, first of all, I need this to be a little clearer, a little more focused, because better. All right, so let's take a look at this. It says label W as shown in the diagram. All right, perfect. So I label W. Now, this is what we always write when we write a proof. We usually write the given statement first. Okay? But here, right now, they're telling us to prove that x plus y equals z. That's all I'm asked to prove. So let's take a look at an approach of conducting this proof. So we know that x plus y plus w, okay, add up to 180, because the angles in a triangle, right, sum to 180. All right, perfect. Oops, sorry, Candy Crush. My bad. All right. 180. Now, how do I know that? We say measure of x, y, and w, x, y, and w, sums to 180. That's our statement. Our reason is because the sum of the angles, okay, or the sum of the angle measures in a triangle is 180. Okay. Next, okay, next we understand that z plus w, it's a linear pair. So we say that z plus w equals 180. In our statement, my statement is z plus w equals 180. The reason Okay, as you already know, because this, you got it down pat. We say that because linear pairs form supplementary angles. Okay, so this equals 180. This is also 180. So I can substitute, okay, this 180 with measure of W and Z. All right, so that's exactly what I'm gonna do. So I'm going to write measure of X plus measure of Y plus measure of W equals measure of W plus Z. But what is my reason, okay? Well, the reason is the substitution property of equality. And what does that say? Well, you can substitute equal quantities for equals. In other words, this quantity is 180. So wherever I see 180, I could just write this down. Same goes for this one. So that's why I'm substituting this right here for the 180. And I just broke the tip of my pencil. Oh, damn it. Okay. Anyways, so the substitution. Now, watch this. X, Y, W, Y, Z. What am I supposed to prove? I'm supposed to prove that X plus Y equals Z. That the exterior angle is equal to the sum of the two opposite non-adjacent sides. So there is something called, okay, let's solve this equation. Let's subtract, what can I subtract? Let's subtract, where is Z? Measure Y, okay. Let's subtract W from both sides. So what happens? The W cancels out, right? If the W cancels out, in other words, this one right here, we already know this plus this and this is 180. This plus this is 180. So if I take this out, I'm going to say that this plus this equals the angle Z. So right here, if we remove the W, okay, by the subtraction property of equality. What does the subtraction property of equality say? If we subtract equals from equals, okay, this quantity was equal to this one. So if I subtract equals from equals, the difference is equal. I know, crazy property, but it's true. So now W is out of the picture. Therefore, I have measure of angle X plus measure of angle Y equals measure of angle Z. And that is my proof. I proved it. All right, let's move on. I'm sorry it took too long, but we needed to understand. Okay. So there's a bunch of text right there that you could read on your own right now. Let's see what's going on. I need to prove that vertical angles are equal in measure. I need to prove that this angle W and Y or X and Z are equal in measure. You already know how to prove it. So let us go through the steps. What do you know about angle W and X? W and X. Hello, they are a linear pair. What do you know about angles Y and X? They are a linear pair. Okay? So what do I know? That their sum is 180. Okay? Linear pair, sum is 180. What else? What conclusion can you draw based on both pieces of knowledge? Well, I can draw the conclusion that measure of angle W equals the measure of angle Y. Right? Okay. Now let's write our proof. So, measure of angle W plus measure of angle X equals 180, okay? And the reason being is that linear pairs, okay, these are statements and these are reasons, okay? Maybe you want to write statements and reasons. So the reason is that linear pairs form supplementary angles. Okay? Supplementary angles meaning that they add up to 180. All right, let me just draw the line right here so we know. Statements and reasons. Okay. Next, we are going to say that measure of angle y plus measure, okay, of angle x also sums to 180. Okay, y and x is 180. And what is the reason? Hello, linear pairs form supplementary angles. So linear pairs, and I'm just gonna write little commas right here to denote that I'm writing the same thing again. So they form supplementary angles. Okay. Now that we have said that, then we can say that measure of angle W, okay, plus measure of angle X, okay, equals measure of angle Y plus measure of angle X. Okay, measure of angle W plus measure of angle X, that's a linear pair. Should be the same thing as measure of angle Y plus measure of angle X, another linear pair. Of course, they are supplementary. Okay, now what is my reason for saying that? Let me see. This would be, what did I do? W plus X equals Y plus X. Oh, I use the substitution postulate. Since they both equal to 180, I can substitute equals for equals. So that's why, notice that this went over here. Okay, so then substitution postulate. Actually, they don't call it postulate anymore. I'm so sorry. We're gonna write what they want, okay? Let's not call it postulate. Let's call it substitution property of equality. Okay? Yes? Okay. Therefore, if these two are equals, and let us use the subtraction property, okay? We want to prove that measure of angle W, that W and Y are vertical angles. W and Y are vertical angles. And we want to prove Y. So by the subtraction property of equality, if I take away angle X from both sides, the quantities remain equal. So then, these three little points, these three little dots mean, three little dots I said, not four. Three little dots means therefore. Therefore, measure, the tip. So in all of them I'm losing the tip? That's crazy. So measure of angle W equals the measure of angle Y. Okay? Again, subtraction property of equality. Okay? Alright, let us continue with another proof. Given the diagram to the right, prove that measure of angle W plus measure of angle X plus measure of angle Z equals 180. In other words, they want me to prove that, let me say, W plus X plus Z, W plus X plus Z equals 180. Well, right now, let us conduct an informal discussion. Look, okay, hopefully you can see it. We know that X plus Y plus Z equals 180 because the angles in a triangle add up to 180. Now we know that W and Y, or Y and W, are vertical angles. Therefore, the measure of Y can be replaced by the measure of W because they're the same measure. So then instead of saying X plus Y plus Z equals 180, I could say X plus W plus Z equals 180. So we use the concept of vertical angles, right? We use the concept that the angles in a triangle add up to 180. And now that you understood that, let's write our proof. Okay. So let's see. Okay. Measure of W plus M plus Z. Okay, that's what I'm supposed to prove. Now, measure of Y. Can I see that? No. Oh my God. I don't want to make it so small. So small. Measure Y plus measure of X plus measure of angle Z, okay, equals 180. Okay. Now, what do I base myself on to say that? Well, what is the reason that these three are 180? The sum of the angles of a triangle, okay, the sum of the angles of a, I'm just gonna write that, the word like that. The sum of the angles of a triangle, okay, is 180. Okay. Then I'm gonna go on to say that measure of angle Y is equal to measure of angle W. Okay, Y and W. Now, why would I want to say that? What concept am I using? Vertical angles, okay, are equal in measure. Oh, okay. So now, what else do I need? Well, now that we have that measure of angle Y and measure of angle W are equal because of vertical angles, then I can use the substitution postulate or substitution property of equality. I'm so used to saying postulate because that's what I used to teach. So, therefore, okay, these three dots means therefore, measure of angle W, I'm sorry, yeah, plus measure of angle X plus measure of angle Z equals 180. Okay? And now, what was it? Oh yeah, the substitution postulate, right? I keep on saying postulate. Substitution is going to take me a while to get used to the substitution property of equality. Okay? And that is your two-column proof. Alright, so we paused it. And now we move on to the next one. Okay, so it says, given the diagram to the right, okay, prove that measure of angle W equals the measure of angle Y plus Z. The exterior angle of a triangle equals to the two remote angles. We already know that. Okay, but look at this. We have a Y over here. I don't know why, but it doesn't matter. Okay, let's start our proof. So proving that W equals to Y plus Z. Oh, okay, now I get it. Y plus Z. Please, what do we know? That the measure of W is equal to the sum of the two opposite angles, Z and X. So W is equal to Z plus X. Now we know that X is a vertical angle with Y. So we could just replace X with Y. You understand what I'm saying? And now since we can, okay, since I'm not writing anything, I can make it larger. So once again, this is equal to Z plus X. X is verticals with Y. So I could replace equals by equals. So instead of X, I could just say Y. So then W should be equal to Z plus Y. Okay? Now let me write down the proof the way we're supposed to. So I don't have much space, but I'm gonna try my best. So the first statement is that measure of angle W equals to the measure of angle X plus measure of angle Z. Okay, so now let me put the thingy over here. Now the reason, okay? What is the reason for saying that W is equal to the sum of these two? Easy. The exterior angle, okay? The exterior angle of a triangle is equal or equals is equal to the sum of the two opposite interior angles. Okay? Alright, now to write my next statement. We said that X and Y are vertical angles, so that's exactly what I'm going to do. Measure of angle X equals measure of angle Y. The reason behind it is that vertical angles are equal in measure. Vertical angles are equal in measure. Okay. Now, let's see if you can guess what property am I going to use. So, because vertical angles are equal in measure, then I can say that measure of angle W equals to the measure of angle Y, okay, plus the measure of angle Z. What do you think, what will be the reason for this? What will be the evidence for this claim? I think you're correct. The substitution property of equality. All right, of equality. All right, let's move on to the next problem. Okay, so let's move on to the next page. All right. So I am going to read the problem to you, and then we're going to analyze this. It says, in the diagram to the right, prove that measure of angle Y plus measure of angle Z is equal to the measure of angle W plus the measure of angle X. Okay? So, let's see now. There you go. So now I can increase. Whoa. Okay, better. No. Come on, you could do this. You could do this, camera. Okay. Wow. Okay. So, measure of angle Y plus measure of angle Z. So, Cosmo, please. Okay. So, measure of angle Y plus measure of angle Z equals measure of angle W plus measure of angle X. Well, think of it this way. I know. The way I see it right here is that Y plus Z plus A, okay, are three angles of this triangle. So they supposed to add up to 180. Now let's take a look at the bigger triangle right here. Look, W plus X plus A have to add up to 180 degrees. So then, let's see if I can analyze this. If A is the one missing to complete the 180 between Y and Z, and A is also the one missing to complete 180 from W and X, therefore X and Z should have the same measure and W and Y should have the same measure. So the addition of these two and the addition of these two should be the same. Alright then, so that's not a problem. So let's see now. let's write our proof. Okay, I'm ready to write our proof. All right. Okay. Okay, statement number 1. Hopefully everybody can see this. Statement number 1. Measure of angle A plus measure of angle X plus measure of angle W equals 180. Okay? We know that. We know that from here. A plus X plus W. A plus X plus W equals 180. So, I am going to draw my line right here. Now, my justification, okay, for this is that the sum of the angles in a triangle equals 180. So, the sum of the angle, okay, of the angle measure, the angle measures of a triangle. I'm sorry I'm writing over this, but I need to. You don't have to. You actually could have started over here, but anyways. Okay, of a triangle equals 180. Okay. Now, I am gonna go with the same thing, but for the smaller triangle. So I'm gonna say that. Okay, statement number 2. The measure of angle A plus the measure of angle Z plus the measure of angle Y equals 180. And the reason for my second statement is that the sum of the angle measures of, okay, a triangle equals 180. Even if you're not seeing what I copied, you should be taking dictation of what I'm saying, because I'm speaking very slow. All right, let's move on to the third statement. Remember that A right here is a common angle to both of them. All right. Now, this sum of the angles equals 180. This sum of the angles equals 180. So, tell me if you understand this. All these three angles add up to the same thing that all these three angles add up to, right? So that means that I can say that measure of angles, and I'm gonna put it like this: A plus X plus W. Okay, you're not supposed to do this. You're supposed to write them measure of angle A plus measure of angle X plus measure of angle W, but I'm gonna run out of space. You could use a loose leaf equals the measures of angles, okay, what? A, Z, and Y, right? So A plus Z plus Y. Okay, so I just substituted this 180 for this. So you know what my reason is going to be. It's gonna be the substitution property of equality. Okay? Alright then. Now, remember what I'm supposed to prove. I'm supposed to prove that, okay, that the sum of these two angles is equal to the sum of these two angles. That Y plus Z equals W plus X, which we already know to be true. So I'm gonna say that measure, oh wait, I forgot the therefore. Therefore, three little dots right here like a triangle. Okay, therefore, measure of angle X plus measure of angle W equals measure of angle Z plus measure of angle Y. This is not difficult, it's just hard to understand. It's hard to get into our mindset. It's hard to get the mindset of conducting proofs. So what we did is we subtracted angle A from both sides. So eliminates it. When we subtract equals from equals, because these two quantities are equal, then the result is still equals. So this should be equal to that. So the reason is this subtraction property of equality. Okay. Well, I didn't know I'm gonna have to do this into two rounds. Okay. So this time, okay, we don't have time for this. So let me go and show you, okay, what I have already. All right. So it says in the figure to the right, AB is parallel to CD. So AB, so I'm gonna zoom in so you could see it. Let me focus the spot. Okay, better? Yes. Okay. So it says that AB is parallel to CD. We got these two parallel lines. And that BC is parallel to DE. So we got these two lines right here. All right. Now, they want me to prove that angle ABC is congruent to angle CDE. They want me to prove that angle ABC, okay, let me see if I have a color here so I can mark it. Color, no color. Oh, wow. Who cares about color then? So that angle ABC, that this angle right here, okay, is congruent to angle CDE. CDE. Okay then. So I can definitely say that they are congruent. Now the problem is, why are they congruent? Well, think of this. Okay, let us extend. If I was to extend the parallel lines, right, which I didn't do. Oh, you know what? Let me not extend the parallel lines. Let's go with the proof. Okay. So the first one is, the first thing that you write is the given. They told us that these two lines are parallel and that these two lines are parallel, right? Okay, perfect. So now, my first statement is that, and the reason will be given, because it was given to me. Now, my second statement will be the following. Angle ABC is congruent to angle DCB. Let's see if it's true. Angle ABC, okay, with a different color, please. Angle ABC is congruent to angle DCB. To angle DCB. Are these two angles congruent? Oh, hell yeah. Now, why are they congruent? Well, when you write your reason, okay, so the second one was that these two angles were congruent, and I'll just show you which ones. Well, the reason being is that when two parallel lines are cut by a transversal, the alternate interior angles are equal in measure. Okay? When two parallel lines are cut by a transversal, the alternate interior angles are equal in measure. Okay then. Now, I have those. Guess what? Now, my other reason, it's going to be that angle DCB is congruent, or sorry, is equally measured to angle CDE. Okay? wait, what am I saying? That the angle DCB, this angle, is equally measured to the angle oh gosh, sorry, to the angle CDE. This angle being congruent to this angle. Well, these are parallel lines. If you want to go all the way here, parallel lines cut by a transversal. So this is the interior of the parallel line. So these angles are actually congruent because they are alternate interior angles. So then my third statement is accompanied by my third reason. When two parallel lines are cut by a transversal, then guess what? The alternate interior angles are equal in measure. When two parallel lines are cut by a transversal, the alternate interior angles are equal in measure. Okay? Alright then. So now this is where we go and we say, okay, how come they want me to prove that this angle is congruent to this angle? So I use my alternate interior angles first, and then I continue to use the alternate interior angles later. So now I can basically skip this, okay? I can skip this angle, right? I can skip this angle and say that these two angles are congruent. Okay. So that's exactly what I'm going to say. I am going to, this equals to this equals to that. I can substitute this for this, and so I can say that this is equal to that. So then I finally say that therefore measure of angle ABC is equal to the measure of angle CDE. Okay? And the reason being, well, you already know. I substituted, remember, I substituted this angle DCB, okay, for angle CDE. So angle ABC is congruent to angle CDE. Boom, you have it right here. And the reason being is the substitution property of equality. Okay? Alright then, let us move on to the next problem. Alright. So I am going to just go ahead and show you the diagram. It says in the figure to this, in this figure to the right, okay, prove that the sum of the angles marked by the arrows is 900. These angles marked by the arc is 900. Alright then, how the hell am I gonna do that? Well, I know that these are angles at a point, angles at a point, angles at a point, correct? So that means, and I'm just saying that because like if I do the full revolution, I'm gonna form a circle, and a circle is 360, right? Or you could say that this linear pair on top is 180 and this linear pair on the bottom is 180. So it's still 360. However you look at it, there's no way, you know what? Oh, caught you. It's been a while. All right. So now, what can't I say? I'm supposed to prove that this is 900. So think of it this way. 360, 360, 360. How much is that? Isn't that 1080 degrees? Yeah. But they only want this part, and this part. They don't want this angle, and this angle. So if you look at it, we know that this forms a triangle. This is a triangle. So we know that in a triangle there are three angles, and the sum of the three angles in a triangle is 180. So we know that this was 360, 360, 360, that was 1080. And if we take away the 180 from here, we end up with 900. Yeah, it's easy said and done. But now, how am I going to prove it? Easy. Okay. So basically, let's label this. All right. Let's label this. How do you want to do this? Gosh. Let me see now. DH DHI. Okay, let's label this DHI. Okay, and now let's label. Should I use? I'm gonna use the same pen. You see? Oh man, the lead is bad on this one. The lead is good on this one. I'm gonna label this A, B, C. Okay, I'm gonna label this. Let me see. E, F. Am I doing it right? E, F, G. Oh no, sorry, not this one. I'm gonna label this E, F, G, and then this H. And now I'm gonna label this, okay? So we have I, I'm gonna label this J, K, and M. I don't wanna use L, okay? So now that we label it, okay, there is no fallacy, faulty logic in label this. It's just for, reference. So let's see now. Now I can say that A plus B plus C plus D equals what? OD, 360. Now I also can say that E plus F plus G plus H, 360. E plus J plus K plus M, 360, correct? Okay, because angles at a point form 360, angles at a point form 360, angles at a point form 360. So let me show you then what I wrote as my statements. Okay? So I wrote A plus B plus C plus D equals 360. And now my reason was that angles at a point sum to 360. Then I said, okay, again, the next set of angles. E plus F plus G plus H equals 360. Why? Hello, because angles at a point for sum 360. Then I did the same thing for the other one. Angles at a point, and I got tired of writing, so basically I just wrote the little quotations in there, or little commas. Okay? Good. Now I went and I said that the sum of all the angles, watch, A, B, C, D, E, F, G, H, I, J, K, L, M, and they sum to 1080. Yeah, you cannot see it. I'm gonna show it to you. I'll show it to you. Oops, sorry. See, 1080. Don't even think about it. I'm not tricking you. All right then. Now, the reason being is the addition postulate of equality. Okay? We add them all up. Okay. The next thing I told you, remember? Okay, that this was the 1080. The next thing I told you is that they don't want the whole thing. Okay? They're leaving out the angles in the triangle. So then D, I, and H. So I can say that D plus H plus I is 180, not 1080. Okay. I can't believe I was doing this. Now, they're equal to 180 degrees. If you want me to put degrees, I'll put degrees. Actually, you should put degrees when you have more space. Okay then. So now, these angles sum to 180. So I can substitute these three angles for the number 180. Okay? And that's exactly what I'm going to do. Remember what I did over here. All of them, including D, including H, including I. So now this is going to turn into 180. By what? Hello, by the substitution property of equality. Bags united. I'm nice. Okay, so now let me rewrite this. So instead of writing all the letters, now remember, now we don't have D, H, I. Now we're gonna have 180. So A plus B angle, oh, by the way, if you have more space, you write angle A, angle B. Okay, so A plus B plus C plus D plus blah, 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 plus 180, which is DHI, right? equals 1080. Now, guess what? If I subtract, okay, if I take away the angles inside the triangle, then the 180 becomes 900. So that's exactly what I did. If we subtract 180 from these two quantities are the same. This quantity and this quantity are equals. So if I subtract equals 180 from both sides, if I subtract equals from equals, the resulting difference means subtraction. The resulting difference are equals or stays equal. Got it? And what would be my reason for that? Subtraction property of equality. Yo, Bex, you're nice. Thank you, I know. Okie dokie. Let me tell you something. This is the worst lesson ever. It's like I'm in an English class. I know, you're telling me. Okay, let's look at this diagram. So I'm supposed to prove that, okay, I'm supposed to prove that DC, okay, DC, that DC, this line right here, okay, it's hard, right, is perpendicular to EF, to this line. Let me use a color. Okay, that. And of course, what am I supposed to put? DC, where's this? Oh yeah, DC. Okay, I'm supposed to prove that these two lines are perpendicular. Of course they're perpendicular. Look. They don't look perpendicular to you? They look OD perpendicular to me. It doesn't matter. Alright. So, what facts do we need to keep in mind? Well, first of all, we usually deal with triangles. Okay? So, measure of angle E plus A, okay? Plus, we're not going to say angle F, because it would be very, very general. So, we're going to say EFA. EFA. We're going to say this angle right here. EFA. That's what we call it. EFA. So we know that this angle plus this angle plus this angle, okay, you call it, yes, I could call it F, but no. EFA equals 180. Yes? What else do we know? That EFA is 60 degrees. We know that this is 60 degrees. How the hell is that possible? Hello? Oh, sorry. If this is 60 and this is 60, then this has to be 60. It's an equilateral triangle. Oh, okay, whatever. Alright, what else do I know? I know that this triangle, the measure of 60, okay, 90, and angle CDB equals 180. So 60 plus 90 is 150, correct? 150, so therefore this angle has to be 30, because that's 180. Yes or no? Okay then. Now, funny thing is that the measure of this little triangle right here, okay, what do you want to call it? Let me see. Think of a name for it. Well, it doesn't matter. In this triangle, I want to know what I want to call it. Let me see. I'm gonna call it, you know what I'm gonna call it? I'm gonna call it Z. Okay? So now, this is what I know. The measure of CDB, which is this 130, plus the measure of EFA, which is 60, okay, plus the measure of the angle EZC, okay, adds up to 180 degrees. That's interesting. So EZC is 90 degrees. Okay, now look, you already had this little triangle, okay, and we just decided to call these points Z. We know that in a triangle we have 180 degrees, and all of a sudden we already got 30 and 60. 30 and 60 is 90, so that means that this angle has to be 90. You understand what I'm saying? So this angle is a 90-degree angle. The only way that you're gonna have a 90-degree angle is if the lines are perpendicular to each other. Now the thing is that I'm supposed to prove that DC, okay, DC is perpendicular to EF, okay? So they don't care if this line is perpendicular to this one for the 90 degree. They care that this is also a 90-degree angle because of vertical angles, correct? So then this line will become perpendicular to this one. Okay, so then let's start dealing with the statements and this. Hopefully you'll be able to read the whole thing. Let's start with the statements, okay? It's 7 statements and you have the whole page, so please leave space. I'm just showing it to you so you could see. Okay, now I'm gonna show you the reasons. See, I numbered the statements and I numbered the reasons so you don't get lost. Bastante escritura. All right, this should be enough time for you to copy. Okay, so everything I said is basically what I write in here. Now, guess what? You're not limited to this 2-column proof where you have the statements and the reasons. No, you could write an essay saying, well, and you start, the same explanation that I would give you, that I just gave you, you would write on paper. Okay, so we know that the 3 angles in a triangle form, 180 degrees. We know that this is an equilateral triangle. Okay. Then we also know that this is a right angle. We don't know whether these are perpendicular to each other. We are just assuming, but based on the facts that we're describing, we're going to prove it. Then you end up with this angle being 30 degrees, this angle being 60. So now you know that angle, okay? Now you know that this angle right here, okay? And this angle right here plus this angle right here, that's 90, okay? Plus this angle right here is 180 degrees. So that automatically tells you that this is a right triangle. And if this is 90, this has to be 90, okay? And therefore, if this is 90 degrees, the lines have to be perpendicular because perpendicular lines form 90 degrees. And that's basically what I said, that the lines, look, DC is perpendicular to EF because perpendicular lines form 90 degrees. That's the only way. All right, you're capable of doing this. I believe in you. All right, let's move on. Okay. So now let's start over. All right, so we got this problem right here, okay? And we are going to, it says, in the figure to the right, prove that M is parallel to N. So I'm supposed to prove that this M is parallel to N. So what I'm going to do is I'm just going to draw some angles of reference angles. So for example, angle A, and then I'm going to do angle B. Okay? So let's see what's up. What do I know? I know that A plus 138 equals 180 because linear pairs are supplementary. Yes or no? Okay then. Now I know that the measure of B is 42 degrees, and you know why, right? Cool, yes, vertical angles. All right then. Now the measure of A is 42 degrees. What do you mean? Well, because of the subtraction property of equality. Okay? If you subtract equals from equals, the results are equals. Okay. So anyway, now we know that A is 42. So A is going to be 42. Okay. Why? Again, the subtraction property of equality. If you subtract equals from equals, you get equals. So look at this. Okay? So in other words, I could have said that 138 plus B is 42. What? 138 plus B is 180. So if I subtract B from this, I get 138. All right. So now we know that A is equal to B. Now, why is A congruent to B? Well, if two lines are cut by a transversal such that, okay, a pair of alternate, I wrote interior, but in reality, look at what we have here. Okay, they are alternate exterior angles. So a pair of alternate exterior angles are equally measured, then the lines are parallel. So that's what I wrote. And that's it, that's enough. Alternate exterior angles is enough for me to prove that the lines are parallel. All right, so I'm gonna let you copy. And this word is exterior. I don't know why I wrote interior. Okay, so let's see. Hopefully it's not vanished enough. It's not fainted. Let me see. Okay, there you go. So angle A plus 138 equals 180 degrees. Okay, you got the statements? Let me move a little more to the right here so you can copy the whole thing. These are the reasons, okay? Okay, let us move on to the next problem. Alright, so once again, I am going to let you copy the proof first, okay, because this is hard. So copy the proof first. And then we could move on to the problem. Okay, hopefully this is clear. Got it? Gosh, can I not like get something very clear now? Okay. So I hope you copy the whole thing, so you know that this means substitution property of equality. It's just that it was blurry. I just clicked on it, so it was good. Now I'm not gonna put it in auto. Wow, this thing cannot focus the whole thing. It's okay. All right, let's take a look at the diagram. So let's see if we understand this part right here. Okay, clear now? So we have the diagram, and I'm supposed to prove that measure of angle A plus measure of angle D minus measure of angle B, okay, equals 180 degrees. I really don't know how I'm going to prove that, but anyway, all these three lines are parallel, and this time I am going to extend it, okay? I don't know why I'm extending that, but something tells me that it's the right thing to do. Okay, so let's see what we have in our proof. Measure of angle A, right, is equal to the measure of angle B plus the measure of angle C. Angle A is equal to the measure of angle B plus C. How is that possible? Oh, Becker, you are estúpido. These are alternate interior angles. Oh, okay. So if parallel lines are cut by a transversal, then alternate interior angles are equal in measure. Okay. Now, what else do I know? Measure of angle C plus D. Measure of angle C plus D. C plus D, okay, equals 180. How are these 180? Oh my God, estúpido! Look! This is a transversal! Get it? Parallel lines, transversal, same side interior angles. Oh, yeah, okay. So same side interior angles in parallel lines cut by transversal are supplementary. And anyway, you already copied the whole thing. Okay, so this is 180. All right, so what? So let's take a look at B, okay? Measure of angle A is equal to B plus C. Now, measure of angle A minus measure of angle B, so measure of angle A minus measure of angle B plus D, it's 180. How is that possible? I'm not getting it. Well, angle C plus D is 180. Okay? Angle A plus CB is 180. So angle A minus B becomes angle C. So A minus B becomes angle C. Therefore, angle A plus minus B, okay, plus angle D equals 180. And what would that be? Well, that would be the addition, okay, additive identity property, okay, that if you take away this from an angle, if you add 0 to anything, it's the same thing. 3 plus 0 is 3, right? So that's basically what it means. Okay then, so basically after doing that, I can say that angle A, okay, plus angle D minus B equals 180. And how is that? By the substitution property of equality. Okay? Wow. So that's how you do the proofs. Yeah, there's a lot of writing. Please tell me we're done. Yes, we're done with these proofs. My God, thank you. I mean, this is just the beginning of the proof, but too much writing, Becker. Too much writing. What's wrong? Illuminati. You show me $1. I'll take that $1. Thank you. Bye. Bye. No, bye. I don't want to hear.